Yeah, fine.
Madam, you may please start.
Okay. Hello. Hello.
Madam, please start.
Yeah, Shailaja ma'am, I'm doing. A safe and healthy good afternoon, everyone. You are very lucky to have Sanjeev sir as faculty for teaching circles chapter. This circle chapter is the most important in this 2B textbook, consisting of almost 21 to 23 marks of the total 75 marks. So children, whatever doubts you are having, you should again and again go through the video tubes in YouTube and ask your doubts, because maybe in 1 or 2 days this chapter will be winding up. Thank you. Sanjeev sir, over to you.
Thank you, madam. Good afternoon, children. We have been discussing about relative positions of two circles in the previous class, and some concepts attached to that. So today we are going to solve problems related to the concept which you have taken in the previous class. So what you actually have learned in your previous class, just recall it. We have discussed about the transverse pair of common tangents, and you talked about internal center of similitude, direct pair of common tangents, and external center of similitude. Then we discussed if the points P and Q divide C1, C2 with the ratio of R1 is to R2. When you say R1 is to R2, internally it is internal center of similitude. If R1 is to R2 is externally, then it is external center of similitude. So you can find these values of P and Q in today's session. So we also discussed about the relative positions of the circles. If you got the distance between centers C1, C2 greater than R1 plus R2, the circles do not intersect, and you'll have 4 common tangents, 2 direct common tangents and 2 transverse common tangents. If you got C1, C2 is equal to R1 plus R2, then the circles touch each other externally. So you'll have a pair of direct common tangents and 1 common tangent. So you'll have totally 3 tangents. And if the value of C1, C2 lies between R1 minus R2 and R1 plus R2, then the 2 circles are going to intersect each other. You'll have only 2 tangents between them. And when you got C1, C2 distance is equal to R1 minus R2, the circles touch each other internally. You'll have only 1 common tangent between them. And when you got C1, C2 less than R1 minus R2, we'll have 1 circle inside other circle, and you'll not have any common tangent between them. Okay, so these are the things which you have taken in your previous class. So we'll just work out the problems on these. So the first problem we are going to take is find the internal center of similitude for the circles x square plus y square plus 6x minus 2y plus 1 is equal to 0, and x square plus y square minus 2x minus 6y plus 9 is equal to 0. So you're going to find the internal center of similitude. So when you are saying internal center of similitude, the point of intersection of these 2 circles, the point of intersection of the tangents, they will be between the centers. Okay, so you need to know the position first of all, and you're going to find the point P, which divides the centers in the ratio of R1 is to R2. So what is given here? You got 2 circles. So first circle, if you take, you call it as S is equal to 0. Second circle, you call it as S dash is equal to 0. Right. Now in the first circle, what is going to be the G value here? 2G is 6, so G value is 3. 2F is minus 2, so C value, 2F value is minus 1, and C value is 1. So from that, you can get the center as, take the half of this coefficient and change the sign. So half of this 6 is 3. So change the sign. So minus g is minus 3. And half of minus 2 is minus 1. Change the sign, plus 1. So the center should be minus 3 comma 1. So for circle S is equal to 0, center C1 is going to be minus 3 comma 1. So you want to find the radius, square this in the root, square minus 3, so it is 9, square 1, it is 1, minus C. So minus C value is plus 1, so it is minus 1 here. So 9 plus 1 minus 1. So 9 plus 1 minus 1 is root 9, which is equal to 3. So the radius of the first circle is 3 and center is minus 3 comma 1. Now we take second circle. Here you got 2g is equal to minus 2 and 2f is equal to minus 6 and c is equal to 9. So when you take the half of this, you're going to get minus 1. Change the sign, it is plus 1. Then half of this is minus 3. Change the sign, plus 3. So the center should be 1 comma 3. And radius, square of g, 1, square of f, minus 3 whole square 9 and minus 9. So you got plus 9 here, so you get minus 9 here. So 1 plus 9 minus 9, it is square root of 1. Square root of 1 is 1. So you got radius R1 as 3 and R2 as 1. So when you take this, the point P should divide C1, C2 in the ratio M is to N, right? Whenever you say the point P divides C1, C2 in the ratio M is to N in your 10th class and first year 1B, you have discussed this formula. What is that you're going to take? The formula is mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. So this was called as the section formula. Now you can say this point as internal center of similitude because you're talking about the word internal center of similitude. So the ratio is going to be internally and it is going to be internal center of similitude. Now you got C1, x1, y1 value given, which is C1, x2, y2 value given, which is 1 comma 3. Radius R1 is 3, R2 is 1. So you can say ratio of radius R1 is to R2 is 3 is to 1. So here R1 is to R2, you can write it as M is to N because you use variables as M and N. Then R1 is to R2 is M is to N, which is nothing but 3 is to 1. Now, center C1 is given as minus 3 comma 1. Center C2 is given as 1 comma 3. So you got M value, N value, X1, Y1 values, X2, Y2 values. Substitute these values in this formula and get me the value of P. Can you get the value of P from this? Substitute the values and find the value of the point. So M is 3. So 3 into X2. X2 is 3. 3 into X2 is 1. So 3 into 1 plus 1 into X1. X1 value is minus 3 divided by 3 plus 1. So 3 into 1 plus 1 into minus 3. Now Y values you take M Y2. So 3 into Y2 is 3 here plus N. N is 1 here and Y1 is 1 here. So 3 into 3 plus 1 into 1. So 3 into 1 is 3. 3 minus 3, you get in numerator. 3 plus 1 is 4. Then 3 into 3 is 9. 9 plus 1 into 1 is 1. So 9 plus 1 is 10. So you got 3 minus 0. 3 minus 3 by 4. 9 plus 1 by 4. So 3 minus 3 is 0. 0 by 4 is 0. 9 plus 1 is 10. 10 by 4. So the point you get is 0 comma. You can say 10 by 4 as 5 by 2. So this is what is the point called as the point of internal center of similitude. So when you got internal center of similitude, you take the ratio as ratio of radii R1 is to R2, which you can call it as M is to N if you wish. If you are directly taking R1 and R2, no problem, you can just use it. Now, instead of internal center, if the question is asked, find the external center. So the point will be somewhere not between C1, C2, it will be outside C1, C2. So you can say the ratio as M is to N externally or R1 is to R2 externally. Okay, so that you can always take it as instead of using a word externally, you can use a ratio as R1 is to minus R2 or minus R1 is to R2. So remember this, whenever you got externally, you have to use one negative sign either for R1 or for R2. So R1 is to minus R2 or minus R1 is to R2, and use the same formula. Or else, if you don't want to change the sign here you have to put a minus sign between them. So the formula is going to be mx2 minus nx1 by m minus n. Same is the case with y here. So you got two choices. Either you can put a negative sign here, or you just change the sign of the one of the radii. Because it is ratio, no need, it is not going to affect. Okay, so R1 is to minus R2 or minus R1 is to R2. If you take and use the same formula, you get the same answer. So try to do a problem on the external center of similitude later. So let us take another problem here. Show that the circles x square plus y square minus 6x minus 9y plus 13 is equal to 0. X square plus y square minus 2x minus 16y is equal to 0 touch each other. The first question, you have to show that they are touching each other. Second, find the point of contact. So whenever they are touching, you will have a point of contact. So you're going to find the point of contact, and you're going to find the equation of common tangent between these 2 points. So whenever they're touching, you're going to get a tangent. Only one tangent is possible. So you're going to find that equation of tangent. Okay, so whenever you say they are touching, there are two possibilities. One is C1, C2 is equal to R1 plus R2. Second is C1, C2 is equal to R1 minus R2 in the modulus, mod of R1 minus R2. So you have to check whether it is touching internally or whether it is touching externally. So for that, you're going to find the centers and radius. What is given here? Circle equations, S and S dash. Now in this circle equation, what should be the center? Half of this, and half of this with the same sign. So here minus 6 half is minus 3, change the sign, plus 3. Minus 9 by 2 half is minus 9 half is minus 9 by 2, change the sign is plus 9 by 2. So the first center should be 3 comma 9 by 2. So C1 is 3 comma 9 by 2. So radius is going to be square root of this 3 or square of minus 3, 9, square of minus 9 by 2, 9 square is 81, so 81 by 4. Then you got plus here, so you're going to get a minus sign here, so minus 13. So 9 plus 81 by 4 minus 13. So 9 minus 13 is minus 4. So you can take LCM. So you get 81, you got minus 4. So minus 4 into 4 is 16. So 81 minus 16 divided by 4. 81 minus 16 is 65. And square root of 4 is 2. So you can write as square root of 65 divided by 2. So the radius of first circle you got as root 65 by 2. Now you take second circle here. So second circle, you got 2g value as minus 2, 2f value as minus 16. So the center should be equal to 1 comma 8. So for circle S dash, center Hello, am I visible? term. Hope that I am visible. You got two circles given. You got S dash. So you got center C1 is 3, 9/2. Radius is given as square root of 65/2. Now you take second circle. Center is 1, 8. So radius should be square root of 1 square plus 8 square. Now there is no constant here, so you get 1 plus 64, which is nothing but root over 65. So you got second radius as root 65. Now you're going to take the distance between the two circles because you are going to check whether they are touching each other or not. So distance between the center C1, C2. So how to find distance between 2 points? You got a formula x2 minus x1 whole square plus y2 minus y1 whole square. So 3 minus 1 whole square plus 9/2 minus 8 whole square. So 3 minus 2 is 3 minus 1 is 2. So 2 square is 4. And 9/2 minus 8 is 9 minus 16. 9 minus 16 is minus 7 by 2 whole square. So you get it as 4 plus minus 7 square is 49 divided by 4. So when you take LCM here, 4 is LCM, 4, 4, 16. 16 plus 49 is 65. So you get root over 65 by 4. Square root of 65 by root 4 is 2. So you got the distance between the two centers as root 65 by 2. So now got your R1, R2 and C1, C2. Now you have to check what is the difference. So you have got two options here. You can check R1 plus R2. When you take R1 plus R2, what you get is root 65 by 2 plus root 65. So it is going to be 3 root 65 by 2, right? So definitely they are not externally. So for that, we have taken R1 minus R2. You have to judge yourself whether you are going to take R1 minus R2 or R1 plus R2. If at all you are not working out for R1 plus R2, you try for R1 minus R2. So here R1 minus R2 is root 65 by 2 minus root 65. So root 65 by 2 minus root 65 is minus root 65 by 2. Because you have got a modulus, you can write as root 65 divided by 2. So root 65 by 2 is nothing but C1, C2. So R1 minus R2 difference is equal to C1, C2. So when you got R1 minus R2 is equal to C1, C2, what is the conclusion you can make? Whether they are touching internally or whether they are touching externally. So because it is R1 minus R2, the circles should have touching internally. So you'll have two circles touching each other internally. So circle C1, C2 touch each other internally. Now observe the positions of C1, C2 and the position of Q. Where is the point of contact? The point of contact of two circles is at Q. And C1, C2 are lying beside each other. So you see that the point Q is dividing C1, C2 in the ratio, some ratio externally, because the point Q is outside between, not between C1, C2 here. So the Q divides C1, C2 externally, right? So if at all you got the point Q somewhere here, you can say it is internally. You get internal center of similitude. So if the point is outside, you're definitely going to get the external center of similitude. So if the point Q divides C1, C2 in the ratio M is to N externally, the ratio is taken as M is to minus N. Just the previous slide you have taken it up. Now you see why you get the minus sign. You just need to understand. Now here you got C1, C2. So what is that you have done is from C1 you have gone to the point Q. But where you are supposed to reach, you have to reach actually C2. You have to go from C1 to C2. But you have taken extra distance up to Q. So the extra distance is waste. No? So you have to come back. Come back to the point C2. So when you come back, you are going to take the negative direction. So it is M is to minus N. Okay, so if the point Q divides C1, C2 in the ratio M is to N externally, then the ratio is taken as M is to minus N. Right? If you don't want to take the minus sign here, you have to change the formula by putting the negative sign between the terms. So by section formula, the Q should be equal to mx2 plus, you see, minus nx1 by m plus minus n, my2 plus minus n of y1 by m plus minus n. So try to apply this, but of all, you are going to have the ratio. So what is R1 is to R2? R1 was root 65 by 2, and R2 is minus root 65. So you got same term root 65, you can cancel it off here. So you get 1 by 2 is to minus 1. So you got 1 by 2 and here you got minus 1. So what is it you do here in your schooling? What you have done, you wrote this minus 1 as minus 2 divided by 2. So seeing the denominator is same. So once the denominator is same, you have to check the ratios of the numerator. So what is the ratios of numerator? 1 is to minus 2. So the ratio in which the Q divides C1, C2 externally is 1 is to minus 2. So use the section formula here. So the point of contact, M value, N value as minus N, then you got X1, Y1, you got X2, Y2. So substitute the value here, M 1, right? X2 is 1 plus minus N in the bracket. X1 is 3. So by denominator 1 plus minus 2. So 1 plus minus 2 is 1 minus 2. Likewise, Y values. M Y2 is 8 plus minus 2 into Y1. Y1 is 9 by 2 divided by 1 minus 2. So you can just cancel this 2 and 2 here. You get 1 minus 6. 1 minus 6 is minus 5. Minus 5 by minus 1. Then 8 minus 9 you get. 8 minus 9 is minus 1. Minus 1 by minus 1. So you get 1 minus 6 by minus 1, 8 minus 9 by minus 1. 1 minus 6 is minus 5 by minus 1, and minus 1 by minus 1. So you got the point as 5, 1. So you have got the two circles touching each other internally, but the ratio is externally. See the difference. Circles touching each other internally and the ratio is external ratio. So the point of contact Q is 5, 1. So two aspects of this problem is over. Third aspect of the problem. So once you know that the 5, 1 is a point on the tangent, you can find the equation of tangent. So what is the equation of tangent? You got a formula x1 plus y1 plus g into x plus x1 plus f into y plus y1 is equal to 0. So you can choose any of the circles, circle 1 or circle 2, doesn't make a difference. So we have chosen circle 2 here because it was not having constant. So x1 is 5, y1, y into 1 plus g value is minus 1 there. So x plus 5, f value is minus 8. So minus 8 into y plus y1 is 1. No constant is equal to 0. So it is 5x plus y minus x minus 5 minus 8y minus 8. So when you simplify this, 5x minus x is 4x, y minus 8y is minus 7y, minus 5 minus 8 is minus 13. So the equation of the common tangent of the two circles is 4x minus 7y minus 13 is equal to 0. So you got three aspects, whether the circle touching internally or externally, you have to decide. After discussing that, after finding that, then you are going to use a section formula. If it is externally, you get the ratio internally. The circles touch internally, the ratio will be externally. So reverse. If the circles touching externally, the ratio will be internally. If the circles touching internally, the ratio will be externally. It will be reverse of that. Okay. So you get the common tangent like this. There is one more procedure of finding the common tangent. Once you go to the system of circles, very easy to find the common tangent. You know what is circle S. You know what is circle S dash. Simply take S minus S dash. So the first circle minus second circle or second circle minus first circle. So when you do that, the x squared, y squared term will cancel off the coefficient of x, coefficient of y, and constant terms together. You get. So the common tangent is given by S1 minus S2 is equal to 0. Internally or externally, then you have got the section formula. Whether it is, if it is circle touching internally, you get external point. Circle touching externally, you get internal point. Then you got the equation of the common tangent. So the next question, a very, very important question. Carefully listen to this problem here. Find the direct common tangent of the circles x square plus y square plus 22x minus 4y minus 100 is equal to 0. And second equation of circle is x square plus y square minus 22x plus 4y plus 100 is equal to 0. So you're talking about the circles to be direct common tangents. So recollect yesterday's class, whenever you got a circle, you'll have 4 tangents, 2 pairs of direct common tangents, 2 pairs of transverse common tangent, pair of direct common tangent, a pair of transverse common tangent. So if at all you want to have a pair of direct common tangent, what is that you do? What is that you do here? You draw the 2 circles, then you have to check the condition, right? So first of all, you are going to take up the basic aspects. What is the basic aspect? Find the centers and radius of the circles. So first you got circle S given, second circle given here. So what is the first center of the first circle? So it is going to be minus 11 plus 2. So minus 11 comma plus 2. Radius you want to find, square this 121, square 2, 4, and here you got minus 100. So when you have this, you got a formula g square plus f square minus c. So here minus c value is minus 100. So minus of minus 100 is plus 100. So it is going to be 121 plus 4 plus 100. So it is going to be square root of 225. So you get the value of radius as 15. Take the second circle, S dash. So here you got minus 22. So the center is going to be half of this, minus 11, half of this, 2, change the sign. So 11 comma minus 2. Square this to get the radius, 121, square this, 4, 121 plus 4, and you got a plus 100 c value here, so you get minus 100. So when you got a plus here, you get a minus. When you get a minus here, you get a plus. So 121 plus 4 minus 100. So it is going to be square root of 25. So 121 plus 4 is 125. 125 minus 100 is 25. Square root of 25 is 5. So you got radius R1, you got radius R2. Now you're talking about direct common tangents. So once you talk about direct common tangents, the point wherever the circles are intersecting will be externally. See here, these 2 tangents, you got tangent AP and tangent this tangent. These 2 tangents are called as direct common tangents in your previous class you took. And this tangent, they are called as transverse common tangents. So because you are talking about direct common tangents, we're only concentrating on this one. Now see where they are meeting. The C1, C2, if at all you extend up to P here, the line C1, C2, P, the P is going to be an external point. Okay, so the ratio is going to be taken as R1 is to minus R2. Now, where you are going to put a minus sign, it all depends upon you, right? You can take either of the sides, but whenever you see that the C1, C2, and afterwards you got P here, the right side of C2 you got P here, you are going to put the negative sign for the second term. The P happens to be on this side. Say this bigger circle, this smaller circle, and these 2 circles are meeting somewhere here. The P will be here. So the P will be near to C1. So there you are going to take minus R1 is to plus R2. It is only a convention, right? So ratio is taken as R1 is to minus R2 because the point is somewhere on the right side of P, right side of C2. So P is on the right side of C2, right? So ratio is R1 is to minus R2. So R1 is 15 and R2 is minus 5. So you can see that this multiple of 5. So it is 3 is to minus 1. So you can call it as M is to minus N for convenience. So the external center of similitude, because you're talking about direct common tangents, they meet externally. Once they meet externally, you get naturally the external center of similitude. So the point P divides C1, C2 in the ratio of R1 is to minus R2 or R1 is to R2 externally. So the P value, if at all you take use the formula mx2 plus nx1 by m plus n, my2 plus my1 by m plus n. So mx2 here, m is m is here 3 and x2 value is here 11. This is what is x2. Then plus minus 1, n is negative sign, so minus 1 into x1 value is minus 11. So 3 into 11 plus minus 1 into minus 11 divided by m minus n, m plus minus n or m minus n. So m plus minus 1, m 3 plus minus 1 is 3 minus 1. Likewise, m is 3, y2 is minus 2 plus n is minus 1 into 2 divided by 3 plus minus 1, so simply 3 minus 1. Now 3 into 11 is 33 and minus 1 into minus 11 is plus 11. So 33 plus 11 is 44. And here 3 into minus 6 is minus 6 and minus 2. So minus 6 minus 2 is minus 8. So you get 33 plus 11 divided by 2 and minus 6 minus 2 divided by 2. So you get 44 by 2 and minus 8 by 2. So 44 by 2 is 22 and minus 8 by 2 is minus 4. So this is what is the first process. You're going to find the internal center or external center. Because it is direct common tangent, you're going to find the external center of similitude. Okay, so having understood this, so let us go for the next concept or the continuation of this. You got the first external center of similitude. So you got this point P. What are these? Actually, they are the tangents. So before being a tangent, it's a line. So you take the equation of line as something like y is equal to mx plus c. So let the equation of line with slope m. Now here it is passing through the point 22 comma minus 4. So you can use a formula y minus y1 is equal to m into x minus x1. So here x1 y1 is 22 comma minus 4. So y minus 4 is equal to m into x minus 22. Why is that you don't take the next other point? You got another point here. It is up to you. You can choose any point you like. So here we have taken the point external center of similitude as 22 comma minus 4. So from that point only you're going to find the tangent. So the point is 22 comma minus 4. So from the point 22 comma minus 4, you have got the equation as y minus or minus 4. So you can simply write as y plus 4 is equal to m into x minus 22m. Or simply mx minus y minus 22m plus 4 is equal to 0. Now what you got is an equation of a line, but you don't know what is the value of m. So because you have got two tangents, you means that you are going to get two values of m. Okay, so how come you are there is only one m and you are saying two equations? Now because you are going to work out and get a equation. Solving that equation, you are going to get the two values of m from that. Okay, so let us see what happens. So equation 1 is a tangent to circle because it is passing through the A and B here, the previous slide, you can see. So you got this line here, you got a point here. This equation you have taken as y minus y1 is equal to m into x minus x1. So you got this equation, but only thing is you don't know what is the value of m. So equation 1 is a tangent to circle s dash is equal to 0 if the radius is equal to the perpendicular distance. So again the same concept, radius is equal to perpendicular distance from the center. So what is the radius of the circle which you have taken, right? So because you have taken the second circle, radius is 5. If you wish, you can take the first circle also, the radius will be 15. Okay, so the second circle 5 is equal to m into center is 11 comma minus 2 here. So m into x is 11, then plus here minus 1 is there. So minus 1 into minus 2. So you can write minus here and write minus 2, no problem. So m into 11 minus 1 into minus 2. Then this constant. This constant is minus 22m minus 4 in the modulus. Divide by square root of m square plus minus 1 whole square. Okay, so you can expand this. So you can write 11m and minus 22m. So 11 minus 22, 11m plus minus 1 into minus 2 is plus 2, minus 22m minus 4. 11 minus 22 is minus 11m and 2 minus 4 is minus 2. So 5 is equal to modulus of minus 11m minus 2 divided by root over m square plus 1. So you got a root here, you got a modulus here. So what is it you can do is you can cross multiply this. Cross multiply 5 into root over m square plus 1 is equal to minus 11m minus 2. Now you got a square root here, don't have a square. So just squaring on both sides. So when you take squaring on both sides, 5 square is 25. Then square of this is m square plus 1. Then square of minus 11m minus 2 modulus whole square. So when you got minus a minus b whole square, it is same as a plus b whole square. Excuse me. So you can use a minus 11m square is 121m square. Then 2 into 2 into 11, 44m minus 2 square is 4. So expand this, you have expanded this, then you write everything on one side. So what you get is 121 m square minus 25 m square is 96 m square. Then 44 m, 4 minus 25 is minus 21 is equal to 0. So what sort of equation you got? You got a quadratic equation in terms of m. Okay, so how is it you solve the quadratic equation? You can use any of the methods which is available. You can use minus b plus or minus square root of b square minus 4ac by 2a, or you can, if you know the factors, you can use the factors. So here you can write 44 as 72m minus 28m. So you multiply 96 and minus 21 and write the factors, you get 72 and minus 28m. If you are not able to get it, use a formula minus b plus or minus square root of b square minus 4ac by 2a, you get the answer. Okay, so you wrote 44 as 72m minus 28m. Now from these two terms, you got 24 common and m common. From these two terms, you got minus common, 7 common. So 24m, 4m plus 3. And from these two terms, minus 7 is common, 4m plus 3. So you got 4m plus 3 common. So 4m plus 3 into 24m minus 7 is equal to 0. So you got two values of m. One value of m is from 4m plus 3, m is equal to minus 3 by 4. Second value of m is from 24m minus 7, which is m is equal to 7 by 24. So you got the value of m now here. So only thing is you're going to substitute the value of m in the equation of the tangent which you have taken, equation 1. So if you take m is equal to minus 3 by 4, the equation of tangent is y plus 4 is equal to minus 3 by 4 into x minus 22. So cross multiply 4 into y plus 4 is equal to minus 3 into x minus 22. So you get 4y plus 16 is equal to minus 3x plus 66. So minus 3x comes other side, you get 3x plus 4y minus 50 is equal to 0. So the equation of tangent, one of the tangent is given like this. Now second value of m is there. Substitute it here, m is equal to 7 by 24. The equation of tangent is y minus y plus 4 is equal to m is 7 by 24 into x minus 22. So cross multiply this again, 24y plus 24 into 4 is 96 is equal to 7 into x minus 7 into 22 is minus 154. So rearrange this, 7x minus 24y minus 250 is equal to 0. So you got two equations which are the two direct common tangents to the given circle. So the direct common tangents are given as 3x plus 4y minus 50 is equal to 0 and 7x minus 24 minus 250 is equal to 0. So slowly you try to solve this problem. This is one of the very important question for a 7 marks question. So usually every alternate year you are going to get a problem on direct common tangent or a transverse common tangents. So work out on this procedure. You try to solve the problem because there are not many number of problems on this kind. So definitely you have got every chance that one of the few problems come in the examination for IP for 7 marks question. Okay, so practice it properly here. So what is the procedure you are going to take? First of all, you are going to take the centers of the two circles, then radii. Then if it is a direct common tangent, you take the ratio as R1 is to minus R2 or minus R1 is to R2 straight away. Take the ratio. Then after getting the ratio, what is the next step you do here? You're going to get the external center of similitude, because the outside so it is external point, so it means that you are going to get externally. So after getting that point, you are going to get the equation. So equation of tangent, you are going to take y minus y1 is equal to m into x minus x1. So from that, use a usual concept, radius is equal to perpendicular distance from center. So it is again your choice. You can use the first circle or second circle. Okay, so whichever is easier for you, you can take it. Okay, so in the two, you got 15 and second you got as 5. So 5 is smaller. That reason you are taking smaller one. If you want to take 15, your wish. Okay, so and having understood this, let us take the next column here. Again, one more important question. Find the transverse common tangents of the circles. Circle equation given like this: x square plus y square minus 4x minus 10y plus 28 is equal to 0, and x square plus y square plus 4x minus 6y plus 4 is equal to 0. So whether it is direct common tangent or transverse common tangent, initial procedure is going to remain same. So what is that? First, find the centers. So you got minus 4, minus 10, 28 as the coefficients. Minus 4, minus 10, 28. So half of this is minus 2, so change the sign, plus 2. Half of this is minus 5, change the sign, plus 5. So center is 2, 5. Radius, square 2, 4, square 5, 25. And you got a plus sign, so you get a minus sign here. So 4 plus 25, 29. 29 minus 28 is 1, square root of 1. Next, do for second circle. Center is going to be minus 2, 3. Minus 2, 3. Radius 4 plus 9. Again, plus sign is there, so minus is there. So 4 plus 9 minus 4. So 4 cancel off. You get root 9. Root 9 is 3. So you are going to find the transverse common tangent. So it means that the two circles are crossing each other, and the point of intersection will be between C1, C2. So once the transverse common tangent problem is there, the point will be always the point internal center of similitude here, not external center of similitude. So the point P divides C1, C2 in the ratio 1:3. So ratio is 1:3. Why plus sign? Because they are transverse common tangent. So transverse common tangent means internal center of similitude. So what is internal center of similitude? Again, use a formula. M, you can call it as ratio is 1:3 here. So M is 1, N is 3 here. So M 1, X2 is minus 2 plus N 3, X1 is 2 here, divided by 1 plus 3. Likewise, My2 1 into 3 plus 3 into 5 divided by 1 plus 3. So simplify this. 1 into minus 2 is minus 2. 3 into 2 is 6. So minus 2 plus 6 and 3 plus 15, 18. So minus 2 plus 6 by 4, 3 plus 15 by 4. So minus 2 plus 6 is 4, 4 by 4. And this is 18 by 4, which is nothing but 9 by 2. So the point is going to be 1, 9 by 2. So because it is transverse common tangent, you are going to get the internal center of similitude. So from here onwards, the process is going to remain same. First, so equation of tangent with slope M is given as y minus y1 is equal to M into x minus x1. So y minus y1 is 9 by 2. X1 is 1. So M into x minus 1. Simplify this. So you can write 2y minus 9 is equal to, because LCM is 2 here, so 2y minus 9 is equal to 2 is coming other side. So 2mx minus 2m. So rearrange this. 2mx minus 2y plus 9 minus 2m is equal to 0. So again, you observe that this equation is a equation which is having only one unknown. So you are going to get the value of m. So out of two unknowns, you got one unknowns left. So out of three unknowns, x1, y1, you got here, only one is left out. Okay, so this has to be found out. So to find out what is the you use, again you use the same concept. Radius is equal to the perpendicular distance from the center. So equation 1 can be tangent to the circle s is equal to 0 if radius is equal to perpendicular distance from center c2 2 comma 5. Again, why c2? If you wish, you can take c1 also, right? It is your choice. So radius is 1 here is equal to perpendicular distance formula ax1 plus by1 plus c by root over a square plus b square. So 2m into 2 plus minus 2 into 5, then 9 minus 2m divided by a square. A is 2m square plus 2 square. So you can write 1 is equal to 2 into 2 4m minus 10 plus 9 minus 2m divided by root over 4m square plus 4. So you can write this as 4m minus 2m is 2m, 2m minus 10 plus 9 is minus 1. So you just cross multiply now here. Root over 4m square plus 4 is equal to mod of 2m minus 1. So you're going to go for squaring on both sides. When you go for squaring on both sides, 4m square plus 4 is equal to square of 2m minus 1 whole square. Squaring this, 4m square plus 4 is equal to 4m square. Now a minus b whole square. A square 4m square 2 into 2 4 minus 1, so minus 4m plus 1. Now what you are observing is this 4m square is getting cancelled, and you got 4m square cancelled off. So you get equation 4m minus 3 is equal to 0. So there is no m square term. See, if there is no m square term, see, you are supposed to get two values of m. But what is happening here? M square is getting cancelled. What is the meaning of it? So try to analyze this. So you need to get a quadratic equation, but you're getting a linear equation. When you have got a linear equation, it means that you get only one root, but you're supposed to get two values of m because you got a pair of tangents. You're getting only one tangent. So when you got the m square term getting cancelled off, it means that one of the slope is infinity. So m is equal to minus 3 by 4, and since m square term is eliminated, slope of the other line is infinity. It's very important observation you make. This problem generally you get in transverse common tangent. So you get only one value of m. Second value of m, to find out you are going to take the value of m as infinity because second degree terms is getting cancelled off. So if you take m is equal to minus 3 by 4, the equation of tangent is y minus y1 is equal to m into x minus x1. Same formula again. So 2y minus 9 by 2 is equal to minus 3x. Minus or minus is plus 3 by 4. Cross multiply. So 2 into 2y minus 9 plus, if you all rearrange it, you get the equation as 3x plus 4y minus 21 is equal to 0. So you got the equation of the tangent. Next, you take second value of m is equal to infinity. So infinity you can write as 1 by 0. So then the equation of tangent is y minus y1 is equal to infinity. You can write 1 by 0, 2 by 0, whatever it is, no problem. So you're taken 1 by 0 into x minus x1, x minus 1. So cross multiply here, 0 goes to the side. So we get the equation as x minus 1 is equal to 0. So the second tangent will be always parallel to the y-axis. So you got x minus 1 is equal to 0. So you got a pair of tangents. One is 3x plus 4y minus 21 is equal to 0. Second is x minus 1 is equal to 0. So the equation of transverse pair of common tangents is given as 3x plus 4y minus 21 is equal to 0 and x minus 1 is equal to 0. So almost all the procedure remains same. Only at this point you have to take a decision because you have got the m value, only single value of m. second value of m is required. That reason, because you are saying that m square term is missing, slope of the other line will be infinity. Just go back to your first year concepts 1b, you will come to know about this. Okay, so you have got a pair of common tangents given like this. So understood, children, here? So the two problems which you have taken requires lot of practice, requires lot of attention of you, and you need to revisit these slides again and again and try to solve it. Okay, so with this, we just end the session. Like, we just recollect what we have done here. We have done problems on internal center of similitude and external center of similitude. Then problems on relative positions of tangents, point of contact, and equation of common tangent. And we have done problems on direct common tangent and transverse common tangent. Okay, so with this, you can try to solve some practice problems here. I have given 4 problems here. You can also try like the problem which you have done for direct common tangent, do for transverse common tangent, reverse, right? For direct common tangent, instead of direct common tangent, find the transverse common tangent. For instead of finding a transverse common tangent, do the direct common tangent. So there you can have 2 more problems, right? So you just try to practice here, find the external center of similitude. So you got 2 circles here. When you say external center of similitude, ratio should be either R1 is to minus R2 or minus R1 is to R2. Then 2 circles touching each other. So again, you're going to find centers. You have to see whether C1, C2 is equal to R1 plus R2 or C1, C2 is equal to modulus of R1 minus R2. Then find the point of contact and equation of common tangent. Okay, then show that the 4 common tangents can be drawn for the circle given by. Now here, you have to show that 4 common tangents can be drawn. So how is it you know that 4 common tangents can be drawn? If you are able to show that C1, C2 distance is greater than R1 plus R2, you see that the 2 circles are not intersecting. You will have 4 common tangents. So once the 4 common tangents are there, you can find both the internal center and external center for the same problem here, right? Then prove that these 2 circles have exactly 2 common tangents. So when can you say 2 circles have exactly 2 common tangents? Recollect, when can you say circles have exactly 2 common tangents? Whenever the 2 circles are intersecting each other, not touching each other, intersecting each other. If C1, C2 lies between R1 minus R2 and R1 plus R2, the 2 circles are intersecting each other. So once they are intersecting each other, definitely you get common tangents. So also find the point of intersection of these tangents. So you can just try to work out on this 4th problem, the 4 problems, and also the 2 problems which are given. Try to practice it, right? So I hope that you have understood this today's session. If you're not understood, repeatedly see the video and try to work out. Okay. So with this, I would like to address any of the doubts if at all the students are having.
Good afternoon, Sanjeev sir. There are no queries, sir. No questions in today's class. And Sanjeev sir is explaining every minute step very clearly. So I think students, whoever do not understand now, you can go and watch every time. You can go and watch in the YouTube and make a note of whatever important points are there, because this topic, whichever has been dealt today, that is direct common tangent and transverse common tangent, sir already informed you that every alternate year, 1 essay marks question, 7 marks question will be coming from this topic. So thank you, sir. I think circles chapter is winded today.
So one more concept is there, finding the pair of tangents. S1 is equal to S11. Yeah, S1 is equal to S11 concept.
Okay. So tomorrow will be the last session, maybe.
Next class will be the last session.
Okay, 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 sir. Thank you very much.